Welcome to everyone. This is the sixth virtual UNISEC global meeting coming to you live from Japan. And our first speaker is Professor Nakasuka, University of Tokyo. No introduction for him because he's already spoken at this UNISEC global meeting several times. So without further ado, Nakasuka Sensei, you have the floor.
Okay, thank you very much. Hello, everyone. Thank you very much for joining the sixth virtual UNISEC global meeting. My name is Shinichi Nakasuka. And let me start today with this picture. I found this picture occasionally. It was the Aris 2001, about 20 years ago. So this year, we started the comeback competition in Aris. The comeback competition, we designated a certain target point on the desert, and the CANSAT, which was released from the rocket, should go back autonomously to this target point. And the one which comes nearest to the target point will win the competition. And so this was the first year of this comeback competition. And fortunately, this is me 20 years ago. I was still very young. I'm still young. And the University of Tokyo, fortunately, won this competition with a record of the 650 meter to the target. It was not so good, but this was very memorial first comeback competition. And let me introduce several persons from our university which participated in this list. And so this guy, Dr. Tsuda, who was the project manager of Hayabusa 2, who made a presentation in the last month's UNICEF global meeting. And this guy, Dr. Sako, who went into the Canon Electronics, and he made a satellite already twice, and the 1 meter resolution was already achieved. And this guy, Ukawa, is now in Merco, Mitsubishi Electric Corporation, and he is one of the very important guy for the satellite development. And this is Miyamura, Professor Miyamura, who is a professor at the Meisei University in Japan, and he is teaching about space technology. And this guy is very unique. He left our laboratory and went to the MIT and got a PhD, and then joined JPL, and then now he is working for the SpaceX. And I heard that he is working on the control system of the reusable rocket of the SpaceX. So in this way, so many persons who started their, a space technology job in this Alice, now is working very hard for the space development. So I'm very happy in this situation. So today's special guest, I'd like to introduce Dr. Tatsuya Arai. So he participated in our satellite project, and he moved to the United States for studying spacesuits. He's every time said that, I want to study about a spacesuit. So in Japan, he cannot find any place to study about a spacesuit. So that's why he went to the MIT. And he got a PhD over there. And I think he's more an artist than an engineer. And he made a lot of engineering contribution to the space field. But also, I'd like to mention that his biggest contribution to UNISEC is that he made this logo of the UNISEC. It's very, very good logo. Okay, very inspiring. And also, he made a lot of design of the T-shirts of the UNISEC like this. Okay, so this is a 2020 new design, and the another one is like this. It's very good. Okay, and also like this, and like this. So I'm very happy to welcome him tonight, and I'm very much looking forward to his talk tonight. And finally, I'd like to show you today's messages. So in Japan, and we call that the ge wa mi o tasukeru. In English, arts brings bread. So not only the space field, but also you should get some, how can I say, capability different capability by yourself. That is very important. Arts brings bread. And the space is very interesting. Space itself is a very important area, but not only the space, but also it should be combined with some other areas. So that is very important. Importance of synergy between space and other fields. For example, if you combine space and agriculture, what can be possible? What would be possible? Please consider. Then the space will make a very, special contribution to, increase, for example, the crops of the agriculture field or so. So in this way, space will make a very big contribution to other fields. So please consider what will be a very good synergy between space and other field. This is my message today. So please enjoy tonight's or today's UNICEF Global Meeting. Thank you very much.
Professor Nakasuka, thank you. But could you explain a little bit more the first message?
Mm-hmm.
I don't really understand what you're saying.
Art brings bread. If you have a very special, arts or special something like, I can say, capability, it will bring you bread. You can earn money using that, capability of yourself.
But
and
does that really correspond to the Nihongo that you have there?
Yes, yes.
Oh, okay.
Okay, anyway, yeah. Thank you very much.
So, I was going to introduce our speaker, Dr. Arai, but Nakasuka Sensei has already done that. So let's go directly now to the main speaker today. Tatsuya Arai from Oceaneering Space Systems. Please begin.
Okay. Hi, everyone. Can you see my slides?
Yes.
We can.
Great. Yeah, thank you very much for the kind introduction and opportunity tonight or today. Like Professor Nakasuka mentioned, I'm a life support engineer right now at the Oceaneering Space Systems. And as Dr. Maeda introduced me, I'll be talking about the applying UNISEC experience to human spaceflight. So this is my personal perspective, a life support engineer's perspective. I'd like to share how the arts bring bread, or how you can acquire transferable skills through the UNISEC experience. You can apply to not only space industry, but also other industry as well. So let me begin with my background. I was fortunate to be part of the very first CUBE satellites, Sci-4 and Sci-5 at the University of Tokyo, Professor Nakasuka's lab, ISSL. That was when I was sophomore and junior, mostly my junior year. That was about 2001, 2002 timeframe. I wasn't in the Alice, but I was in Tokyo to support the activity. That was about when UNISEC was about to be born, and that's how everything started. After that, I joined Professor Machida's lab at the University of Tokyo to major in space robotics. I got a bachelor's and a master's degree there. And as Professor Nakasuka mentioned, I was very interested in spacesuit. It started as a space station. I was really interested in space and arts, like drawing. So I thought the architecture was the first thing that came up to my mind, but the space station or space colony seemed very far-fetched back then. So I decided to work on a spacesuit. I'll talk about the how spacesuit and space station are similar. To pursue my dream, I came to the United States to major in aerospace biomedical engineering and minor in product design. And in Boston, I was working on the cardiovascular research, mostly on system identification. And after I got a degree, I worked in the biomedical industry in Boston. The company was called Smith & Nephew, Advanced Surgical Devices Division, where I designed the surgical devices for shoulder, hip, and knee repair. And then I came to Houston, Texas. It's really freezing right now. I don't know if you follow the international news, but we had a very rare snowstorm, and we're still recovering from the power loss and water pressure loss and everything. But anyway, I'm a life support engineer, so
Can I ask a question?
yes.
Please go back to the previous slide. We have a lot of students listening today. What kind of advice can you give to students who want to study at a top-notch university such as MIT?
I think so. That's a good question. It's simple answer to study hard, but I think it helps to get hands-on experience and shape your career to be a little bit unique, to stand out on your resume in the selection process. For example, I had an opportunity to work on a small satellites, and that's still a very unique hands-on expertise or experience that will shine on your resume or application. And it's also important to build your network. Like Professor Nakasuka wrote the recommendation letter for me when I applied to 3 grad schools in the US. And I think that was a very strong part of my application. So it depends on where you are in your academic career, but in general, I think it helps to get hands-on experience and it builds your network, especially academic network, like professors or very famous postdocs or so. I think those are probably two major key points, I would say, when you want to apply to grad school. I don't have any experience in applying to a university in the US or any other country, so maybe somebody else have more advice about that. My experience is only the PhD program in the US, but that's my advice.
Okay, I think you raise a good point about networks, because often smart engineers think they can do everything alone, but that's not true, right?
Right.
Okay, thank you.
Yeah, thank you. So as today's table of contents, I like to do a reverse chronology. I want to start where I am as a life sports engineer. I want to talk about who we are and what we do. And then I'll also want to talk about the biomedical engineering space physiology. That's MIT and the Smith and Nephew experience. And I want to show how transferable those skills are. And I'll go back to early 2000s when I was working on a space flying robotics at Machida Lab at the University of Tokyo. And then even go further back, number 4 is when I talk about how I got involved in UNISEC. And in the end of this presentation, I'd like to combine my life support engineer job and the art together. And I want to show something special for you all. Life support engineering. So throughout this presentation, I'll talk about how hands-on experience can shape your successful engineering career. I'm right now a life support engineer, and the job is to design a system or subsystem to keep us human comfortable in a harsh environment like space. Space is very dangerous because we have space vacuum, and the heat cycle is plus minus 250 degrees C. And you don't have any 1G, micro or partial gravity. So you have to live in a harsh environment. The object of the job is a spacesuit and ICLS. ICLS means Environmental Control and Life Support Systems. So basically it's about the backpack of the spacesuit and all the plumbing and everything inside the racks of the space station. That's our job. So the picture on the upper right shows the test rigs to test subcomponents for the backpack of the spacesuit or life support systems. They're huge. Of course, they won't fit in the backpack of the spacesuit, but those racks were designed to test the fans, water pumps, and CO2 scrubber, and those important components to be tested on the ground. And life support systems typically include oxygen, carbon dioxide, temperature control, humidity control. Of course, the ventilation, you have to circulate the oxygen, and you want to circulate the pump to cool down your body and body temperature, and also the temperature of the instruments. We also have trace contaminant control. Humans are filthy. Actually, we produce a lot of hairs, dead skins, and we also produce quite a bit of ammonia in the suit. So you don't want to build up ammonia inside the spacesuit. You have to continuously scrub these nasty gases. And currently, I'm working on water recovery from urine. That's not the main topic of these slides, but it's a fun job to do. We also need sensors. I just talked about the pump, but that's to circulate the cold water through your underwear in the spacesuit. It's called liquid cooling in a ventilation garment. So quite a bit of life support systems are there, and our job is to upgrade those using the latest and greatest technology to make it cheaper, faster, better, or make it more efficient. So focusing on the spacesuit, there are two kinds of spacesuits. The intravehicular spacesuit and extravehicular spacesuit. The intravehicular one is like the spacesuit developed by SpaceX, and it's shown on the lower left. Those are meant to be used when you get launched into space and you come back. Just in case the cabin pressure goes down, you want to keep yourself alive, so that's the suit you wear. And also the orange suits, that's a famous one for the space shuttle. And the other kind of spacesuit is extravehicular spacesuit, or EVA, or spacewalk suits. Those are meant to work in a vacuum. It's not worn inside a space vehicle or space station. That's to explore around ISS, International Space Station, or on the moon. And during the Apollo days, this famous picture of Buzz Aldrin, also Neil Armstrong as in helmet reflection. And then currently in the middle, we have a space shuttle and International Space Station spacesuit. That was designed almost 50 years ago, and they're still using it. It was meant to be used for space shuttle mission, but that was a very indispensable part of the International Space Station project. Without this suit, I don't think space station was built. And currently, NASA is working on Artemis spacesuit on the right. That's to walk on the moon. And then the difference between these three, mostly the current spacesuit and Artemis spacesuit, is that there are the main difference is the legs. In the current spacesuit, this is not really designed to walk around the planetary situation. So you just get on the tip of the robot arm or use handrails to move around the International Space Station. So you don't have to walk. So the legs are really stiff. On the other hand, the latest Artemis spacesuit, you have a lot of good ball bearing joints so that you can actually walk on the moon. What are the design requirements for the spacesuit? If you think about it, well, we haven't evolved this fast. I mean, maybe in the last 50 years, or probably at least 500 years, humans didn't really evolve physiologically. So basic requirements are the same. We need oxygen. We have to get rid of carbon dioxide inside the spacesuit, and we need to control the temperature and humidity, and you still need to move around. But at each spacesuit design increment, every time new technologies are implemented to meet those requirements efficiently. So when it comes down to useful skill sets, the life support engineering with spacesuit sounds exotic, but there are a lot of common features or skills that's very transferable from small satellites or hybrid rockets to this kind of job. So you have to get data. So data acquisition is one of them. You want to wire all the sensors and actuators. So that's a good hands-on skills. Not many people actually have that outside in the community. So that's a really good one to have. and simply the engineering A to Z. So you plan tests, you find sensors and actuators, and you design a test, what to test, and you have to safely execute the test and collect data, analyze data, and report. That's very useful for life support engineering as well. And also concise communication is important. You don't want to have long emails. You want to have concise emails. You want to have presentation skills, and also you want to have a scientific writing skills. And what I recommend is engineering diary. You can use PowerPoint or Excel, for example, to write down all the daily progress. Excel is useful because you can use it like a paper. You can just write down anything or anywhere on the cell, right? And then it's text. Everything is text searchable. So I think that's the way I typically write all the progress, like a diary, and that's really useful. And eventually, it's more likely that you present your work in a PowerPoint. So it's nice to start from the beginning. If you have a major milestone, just copy and paste the figures into PowerPoint, and you can use it later. I think as it helps later to save time if you record those diary as you go. I think it helps later. And last but not least, dealing with frustration and challenges. In the CubeSat project or in any other project, I had a frustration and challenges, and that's a very good experience to have actually before you join the industry in other fields. I'm sure you have some experience, like if you pull all-nighters to do analysis, to build something, but in a group meeting, they spend probably 1 to 2 minutes on your work and then move on, and you get frustrated. Oh, I thought I did my work, why? But I'm sure the people are looking at your work and then they really appreciate it, so be patient. I think this dealing with frustration, emotion, and challenges, that's another way of another good experience to have. Speaking of trustable skills, after graduating from MIT, I worked in a company called Smith & Nephew. They make surgical devices to repair your knee, shoulder, and hip. Probably I'm one of the first who worked on a CubeSat and also in the biomedical industry. It's surprisingly, the skills are very transferable. The CAD modeling, mechanical testing. Actually, if you see those surgical device pictures, upper right, for example, almost all the surgical devices are made of anchors, sutures, and metals. They're very mechanic. Of course, there are some biomedical components into it, but the actual interface with the human body is very mechanical. So those mechanical testing, planning, execution, that's what you learn in school, and also hands-on experience at UNISEC. That's very transferable skills in this field too. And data analysis.
Can I ask a question?
Yes.
How did you get this job?
I can tell the exact example. I was looking for a job. I saw that I was about to defend my thesis, so I knew I was looking for a job. And I think there was another department. I was in aeroastro department, but there was a job session in biomedical department. So I sneaked in with my resume in my hand, and this company was giving a presentation to hire some new students. So after the presentation, I gave my resume to the presenter, which was going to be my boss eventually. And they had 1 or 2 internship auditions, and they called me if I'm interested. So I said yes, and that internship led to the job. So
okay, I see.
Yeah,
that's very
yeah,
interesting. In other words, you just have to try many things, right?
Right. Yeah, you have to try. You have to kick the ball, otherwise you never score, right? So keep trying. Oh, it goes off the rail, but I just want to say one thing. If you are, for example, PhD student, and if you go to career fair, maybe nobody's interested in you, but no offense meant. For example, those career fair people, maybe they are hired to hire bachelor's or master's students, so they don't want to spend any time with PhD students. So sometimes when you get a PhD, people think it's really difficult to get a job, but I don't think that's true, but you have to talk to the right audience. But you have to keep trying. You don't know where the right audiences are, so you have to keep trying. Anyway, back to the slide, the statistics. That's a little bit different thing. In the space program, I think you work on 1Z and 2Zs. You work on one device and probably don't do much stats. I could be wrong. But in the biomedical field, you have to convince FDA, for example, in the US or any other medical authorities, you have to repeat a lot of tests to increase the statistical power and then sample number to make it right. So statistics, if you learn statistics in college or anywhere, it seems useless, but actually it's really useful. So just keep your textbooks for your future career, just in case. Since I talked about the medical stuff, I want to also talk about the space physiology. I majored in aerospace biomedical engineering at MIT, so I had an opportunity to work on some space physiology projects. The biggest difference between the space physiology, any medicine, and the satellite engineering is that when you work on the human body or any animal body, it's all about reverse engineering. There's no USB ports or any pin 1, 2, 3, 4, 5, 7, 8, 9 you can get data from. So you have to invasively or non-invasively get data from living things. So that was a very interesting, and then you have to figure out what's going on. It's like a black box. You have to give input and observe the output and figure out what the system is. That was very interesting. A difference between satellite project or rocket project and the space physiology. And as you may know, if you go to microgravity, the fluid shifts derivatively from your legs to the upper torso, and you get the puffy face in day 1. And then we have some volume and pressure sensors around the heart, aortic arch, and you start to pee a lot to reduce the pressure and the plasma volume, the blood volume. So on day 1, you pee a lot. And then that's part of the adaptation microgravity. Motion sickness is another interesting thing. The picture on the right, you see one astronaut upside down, and then that could be a trigger for you when you're in space to vomit. A lot of people have theory about vomiting in a 0G, but one of the interesting explanation I heard was that, so you see a visual cue and your vestibular cue, like inner ear, that's totally different. Something is wrong with your body. What can we do? And brain thinks, oh, maybe we ate something wrong, so let's vomit. So that's why you vomit in 0G. But on day 2, you'll be fine. Your body really just adapt to yourself. It's really amazing that human evolved in 1G throughout entire history, but we're capable of getting adaptation to the microgravity. It's amazing. And we talked about plasma volume loss. We also lose bones, the weight-bearing bones like a heel, because you don't have to walk around fighting 1G. You lose a lot of bones, so you have to keep exercising and give pressure to your legs to make your osteoblast cells working properly. And we talked about inner ear, the balance. I want to talk about this otolith. Certainly it's getting medical, sorry, but this is a tiny cell inside your brain. No, sorry, not in brain, inside your semicircular canal or inner ear. Imagine a little toothbrush, and you have tiny stones at the tip of the toothbrush. And then every time you move, every time you move your head, this brush like swings back and forth, left and right, and giving signal to the brain that, okay, you're moving forward, backward, or you're upside down, or anything like that. So it senses the acceleration or gravity. But in space, there's no gravity if you're in a low Earth orbit. Therefore, you only feel acceleration, and then you adapt your brain to only feel acceleration. When you kick the wall to go to the other side of the space station, then that's when otolith kicks in to send a signal. Once you get used to it and come back to Earth, now you have a gravity as well. So it's interesting thing happens. If you tilt your head back, then this otolith stones go backwards. That means in space, you're accelerating. 1G is huge. So when you tilt your head, you feel like your body is flying forward really, really fast, and then you lose your balance. If you tilt your head forward, then autolysis goes forward, the stones goes forward. That means you're flying backwards really fast. So that's a really weird sensation you would feel after you come up here. After a week, you'll be fine, but it's a really interesting sensation you feel. Another thing, functional task test. So this is a cool test actually. Just to check the physiological changes in the functional performance after spaceflight, you have to do this. You sit down on a chair, and then you unbuckle yourself, stand up, and walk around and dodge those poles and any obstacles, and then climb up the slope. It's a really easy task, but when you come back down to Earth after adapting to microgravity, it's a really difficult job. I heard that one astronaut kept vomiting throughout this course, but nobody's helping you. So it's the job as an astronaut is really tough, but it's a fun test. So I just talked about those space visuality stuff. Now back to more engineering side. During my sophomore and junior year, I supported a CubeSat project. I was there when University of Tokyo and Taitech both launched the first satellite, Sci-4 and the Qt-1. And I still remember Professor Nakasuka shaking hands with Dr. Sako and Dr. Tsuda in the room. So almost 20 years ago. That's amazing. Like Professor Nakasuka said, I was in the thermal team to make some breadboard model, but most of my contribution was arts. Like I made a website for the lab, and also the QSL card on the upper right. That's the card, the postcard you get if you receive a signal from the satellite.
Dr. R.I.,
yes.
You have 3 minutes left.
Okay, thank you. And then this is the space robotics I worked on in Professor Machida's lab. So the goal was to fly the robot through the laser beam. Unlike the traditional laser guidance, you see the reflection. In this case, you fly along the laser beam. You have half mirrors to reflect the laser beam to see those red dots. And then you transfer the coordinates on this plate to see how far you are from the laser beam. And I want to point out that I talked about hands-on skills, but to get the hands-on skills, I think we should look for immersive hands-on experience rather than trying to get hands-on skills. You can move your hands to try to solve the real problems. And to put yourself in a project, join UNISEC. You're already in a UNISEC, and I searched for help, and then Ray mentioned that she can introduce some of the hands-on projects through UNISEC. So I'm looking forward to her slides as well. That was a good segue to talk about UNISEC. This is the logo I made almost 20 years ago. Those colorful satellites represents different satellites, very unique satellites, rovers, rockets, anything. Everybody has different ideas, so let's bring them all together. And this is the fairing of the rocket, because we have not only satellites, but also hybrid rocket people. And I just wanted I wanted the logo to be very inclusive. And then I've been designing t-shirts from 2003 through 2010s to 2020, and more to come. And I also design other logos. So last but not least, I just
hold on. I have good news. You have been granted 3 extra minutes.
Thank you very much. So as I mentioned earlier, I want to bring these arts and the spacesuit stuff together. What can we do? Lego NASA Artemis spacesuit. So during this pandemic, I had some free time, so I decided to make a spacesuit, and NASA said they will bring the suit in 2024. I decided I cannot wait, so I decided to make Lego spacesuit by myself. So it's a 1:7 scale spacesuit, Artemis. All the joints move, and the life support system is also detailed designed, so you can open the backpack to see the life support systems, and you can also open the hatch This is a real rear entry system, unlike the current one. Because I didn't talk about life support system, I can talk about it. So those green cylinders are the O2 tanks. We have ventilation fans on top. We have pressure regulators, CO2 scrubber in the middle, and water evaporating cooler at the bottom above the batteries. So this layout is based on the real NASA documentation or publication. It's all made of Legos. And all the joints move. And we have some accessories. And I put this Lego into the Lego idea competition. Anybody can submit your Lego ideas. And if you get 10,000 supporters, your idea may become the real Lego set. A Lego company will review your ideas. So please vote. It's free to vote. Make an account in Lego website, and you can vote for as many projects as you want. And you can also submit your idea to Lego. It can be castle, it can be some fairy tale stuff, it could be space stuff. Any idea is welcome. So before that, please support my Lego project. The URL is there, and also 2D barcode is there too for your convenience. With that, I conclude my presentations, and if you like, I have my Lego right here in front of my camera. I don't know if you can see in a small screen, but kind of looks like this. Open, you can see the life support system inside. So that will conclude my presentation. Thank you very much for listening. And do you have any questions? I'm more than happy to answer.
Okay, we have time for one question. Does someone want to go?
Okay, I'll just allow everybody to unmute themselves. If you have a question, please proceed.
Yeah, go ahead, Charleston.
Hello. I'm just curious if how do you test the materials for space station? Do you also participate in the testing of and planning of the testing of materials?
Was your question what materials are used in the space station and spacesuits, or sorry?
Oh no, more of how to test the material degradation. What do you use to test them? The materials that will be used.
Oh, I see. I have one experience in the material testing. One of the tests was whether the material survives in a harsh environment like a space radiation. And there is a place called Brookhaven National Laboratory in New York. They have a particle collider, acceleration collider. They can produce space radiation like the proton and also galactic cosmic rays. And they can expose your material to those realistic space, realistic properties of the space radiation. So you can test your material against that. And so that's the material test I know. In terms of other material tests I know is the rocket skirts. That's actually one of the projects my company has to protect the actuators of the rocket nozzle. You have to have a thermal curtain or blanket around the rocket nozzle. And to do that, I think my company does some thermal tests. So again, you bring the realistic environment, like a high temperature flame for duration of blah, blah seconds or so, and then you expose your material to that thermal profile and see if it survives. So I don't know if I answered the question properly, but those are the two space material related tests I know.
Okay, Dr. Arai, thank you very much for a fascinating presentation. Ray, I turn the floor over to you.
Okay, thank you very much. So, let's see. This one, okay. So, I'll talk about, can you see my screen?
Yes.
Okay, thank you. Okay. So I'm going to talk about UNICEF hands-on training experience during the pandemic. Now I'll take two examples, ARIS and CLTP. ARIS stands for Rocket Launch, Rocket Launch for International Student Satellites. And we started this project since 1999, before UNICEF was established. So the it's a canceled experiment and competition supported by AirPac, a mature rocket group in the United States, and they provide rockets up to 4 kilometers and in Black Rock Desert, Nevada, USA. And every year, about 100 Japanese students go to United States and to launch their CANSAT. And the students from more than 10 countries joined this project. But unfortunately, last year we could not organize anything in ARIS, and not very sure this year. Good news is Ken Biba of AirPac will present ARIS project on March 20th, next month, in this is a global meeting. So instead of the ARIS project, the canceled experiment in Asagiri Plateau in Shizuoka Prefecture was organized in December last year. And Japan students found the new location for canceled experiments in Japan, and they're using balloon for launch instead of rocket. So I'd like to insist that what is needed should be considered with innovative, imaginative spirits. Let me talk about Cancer Leader Training Program, CLTP. I'm sure that some of you are from CLTP here. And CLTP is a training program for instructors. Then we invite the professors, instructors, and the graduate students to Japan and conduct the training program of CANSAT or HEPTASAT. And we started this project in 2011. And now we have more than 90 participants, graduates. And we developed the two the educational kits, iCANSAT and HEPTASAT. Recently, we use HEPTASAT, which is more like CubeSat. But if you are interested in CANSAT, you can download full textbook from our website free of charge. So unfortunately, CLTP we could not organize last year. And this year we are still not very sure. So what we are thinking is maybe we should organize online hands-on training. That's why we are developing HEPTASAT Lite, which is simple, cheap kit. And we are planning to develop online course material. And hardware prototype was supposed to be finalized the August last year, but was very slow in development. So in the reality, we are still modifying it, and I hope that we can finalize it in March. My question is, what is online hands-on training, though? Hardware delivery to participants and remote teaching through internet? And real-time teaching or recorded teaching is enough? Or actually, is it effective? So whenever I face difficulties, problems, and questions, I always come back to the guiding principles for UNISEC Global. And I found a good hint. Use imaginative and innovative ways of achieving the maximum result using available personnel, technical, and financial capabilities, even if they are limited. So pandemic just gave us more limitation. So let's go out from the small box, small brain, and be innovative and imaginative. Thank you.
Okay, Ray, thank you for that brief presentation. Nate, is the breakout next?
Yes, it is. It is, George. Thank you very much, Ray. I'll just share my screen with you to give you some instructions. So as Ray mentioned, we're looking at hands-on training in this breakout session. And so this time we'll have 20 minutes, just reduce the time to make sure we stay on schedule. But when you go into your breakout sessions, which I'll open for you in a moment, please set the leader immediately. And then I'd like you to please consider discussing the following topics. What defines good or bad hands-on training? So when we think about hands-on training, what makes that experience a good experience? You know, if you have an instructor who's knowledgeable or equipment that doesn't work properly, what are the things that actually make it good or bad? How can we facilitate better hands-on training when social distancing measures prevent us from meeting together? So are there any ways that we can actually improve it, or any innovations that you can think of? And then how important is the development of personal connections? If we have to try and deliver training remotely, how do we actually foster better relationships with people if we're doing it online? How can we actually have that same level of connection? And how important is that connection if you're working in a group together? And then lastly, how does the online experience impact the way that universities teach their students? And do you think that's something that will last? So these are the questions which we've got together for you today. After the closure of the breakout session, I'd like to ask your leader to please share their ideas. A 1-minute timer will be displayed on the screen for you, and we'll just go in numerical order, in ascending order, from group 1 to, I think I'll probably open 9 groups this time around. And so if you could please just share your thoughts with the rest of us, that would be fantastic. I will post the questions as well to you in a broadcast once I've opened up the breakout rooms.
How much time do they get for breakout?
20 minutes.
Okay. I want to remind everybody that at 11:25 p.m. Japan time, we have the regional report from Turkey. So all the breakout and all the presentations have to wrap up by 11:25. Thank you. Very
good point. All right, fantastic. We'll open up the rooms now. Have fun. We'll see you shortly. Hello, everybody. Welcome back. I hope that you had interesting discussions in your breakout rooms. I'd now like to ask you each to share your group's thoughts with the rest of us. And we'll actually start with room 2 today, if we can. Alim, Aang, Camilla, John, Rigoberto, and Tatsuya. Who is your nominated speaker? Yes, Tatsuya, please proceed.
It was very fortunate. We had a lot of students in our faculty, Professor Aslan, who has some experience in remote teaching and learning. I had 0, so that was very learning experience for me too. I think that what defines good and bad hands-on training, that kind of answers all the other bullet point B, C, and D as well. So I just wanted to share some. It was interesting that somebody mentioned that for the class setting, I think it's important to be able to score your progress for the remote session as well. Something you can score, like a CAD modeling or presentation. Those are easy to score and evaluate. I think that was interesting. And then the kits, if you have kits, that doesn't have to be expensive and has to be locally available. So each country have different situations. So it's nice to have local resources tailored towards each country and setups. And the leading students or teaching assistant may help to sit between the professor and students to lead the subsystems, for example. There are more items, but I think time is up. Sorry.
Thank you very much. Yeah, that's fantastic. Thank you for sticking to the time. Do appreciate it. And room 3, we had Daniel, Koyama-san, Kwanghan, Omar, and Kurosu-san.
Yes, we also discussed the questions that were provided, and we had also people who I think they have experienced this, and they gave very good examples. For example, when talking about good and bad hands-on training, one of the things which came up is that there should be a good kit, and there was the example of the HEPTA kit, which should be available to all the people who are learning. And it was noted that this kind of kit can train about 4 people at the same time. So the groups a large group can be divided into maybe, if it's 20 people, 5 groups of 4 people each, who can be in different places, but the teacher or the tutor can be in a different place. Then there was the importance of having a common design tool, and all the groups will be using the same common design tool, and the teaching is carried on at the same time. I think we had the examples in Taiwan where they actually do that, and they have a place where they can actually handle up to 20 people.
Wow, that's great.
In one interactive class.
Yeah, that's
then
good.
the issue of the interpersonal interaction.
Daniel, sorry, I do have to stop you there. We've reached the 1 minute timer. So
okay,
I'll just thank you very much for your comments, though. And I'd just like to ask if we can move on to the next group, which is room 5. We had Harry, Hoda, Juiching, Nekmi, Pamela, and Tukimi.
Hello, it's Hoda. I would like to speak on behalf of room number 5.
Yes, please.
Okay, so what we started discussing is about like the virtual or remote learning experience, and there was some pros and cons stated there. It was mentioned that generally it was hard to monitor the students, that their grades started to be lower, but also being able to study only the theoretical parts, especially in engineering subjects, was a drawback also for this, because practical and hands-on are limited during this type of learning. But having the lectures recorded and having the ability to contact professors all the time is a good thing for the virtual training. We had a project manager from a satellite project, and he shared his experience how he managed to put the people working together during a satellite project. And he said that we worked on limiting the number of people working in a laboratory by making like rotational shifts and having simple tools for each student at home to be able to work on his progress. So that's all for me. Thank you.
Excellent. Thank you very much. That's a really comprehensive list, actually. And very concise. Thank you very much. Room 7 would be next. It's Anna, Charleston, Urson, Gladys, Sybil, and Siren.
Thank you. So we talked about what can define a good hands-on training, and we believe that a good hands-on training is one that there is constant assistance and monitoring, and also it will be to have the correct equipment to do all the tests, or to have the tools to guide the students in their knowledge, as well as the opportunity to share with most experienced people about how can they do things better. But also in the contrary, a bad hands-on training will be where there is close to zero assistance or delayed assistance. With the pandemic, we know that there are several challenges that we need to take in account, like for example, the internet connection, and that we cannot be physically there, or we cannot be constantly sharing as we would like to do. But we can do it better with online tools and simulations, and also what you are proposing, the kits and the program, that sets a platform for learning in a readiness level of development. I mean, for the product, that you don't need the technical skills so much, because since we are here in the pandemic, everyone is in their houses. Maybe they don't have the technical knowledge to build everything. So with giving something that is standardized, you can focus more in understanding the system and also use it to develop or get data, something like that. But also we
Sure.
can also
All right, Anna, sorry, I'll have to cut you off there. Thank you
Yeah.
very much, especially pointing out actually having access to people with a lot of experience as well. That's a brilliant point that we hadn't really touched on. But we do have to move to the next group,
Yep.
Which is
Thank you.
group 8. Caesar, David, Derek, Mark, Mohammed, Nevson, and Kawashima-san.
Hello, this is Mark. So, to answer the first point, being good and bad hands-on training, for us, good hands-on training is where participants have access to tools and equipment to implement projects, while it's bad when there's no opportunity to implement and do the actual work. There's importance of breakout sessions, whereas there must be some hardware to be distributed, and access to equipment is also important to provide hands-on experience to students, be it a hands-on kit, and there should be a balance between access to online simulation tools and those kits. Secondly, we have toolkits shipped to students if this will not entail much cost to the institution. An alternative training site can also be set up to allow participants to take turn in accessing the site, wherein there's case-to-case basis on the courses on the use of hands-on training. So the difficulty is that projects, you have to take turns because of social distancing and the availability of equipment in the institutions. So we let the students and trainer use the version control of software, simulation tools that are available for everyone so that they can use it at home and they have access to it. Lastly, we would like to enjoin more participants to, I mean, the good thing about this pandemic is that more lecturers are available online despite of them being far from the students. In the same way, we have access to those experts on a certain field so that we can learn from them to provide ideas for the hands-on experience.
Fantastic. Thank you, Mark. The simulation's actually an interesting idea, isn't it?
Yeah.
That's cool. That's a cool option, which I wonder how many places around the world have explored. Thank you very much for your comments. And we'll move on to the last room, which is room 9, which had Chalawat, Chris, Joseph, Mohammed, and Tom.
Okay. Our group started first by defining what is good and what is bad. The good thing that we listed is it should be the hands-on training should be designed according to the audience, and it should have a deliverables in terms of hardware, so it can be more engaging. And the bad one are the one that's are boring and not interactive, and it's too complicated for the time constraint. For the second question, we think that it should require equipment which should be distributed, and it should be like a low-cost open source kit, like DIY stuff, and we should provide technical support and study material at all time. In the third one, we think we should have something like online non-academic activities, like collaboration-based, something like Trivia or Jeopardy. And the third and the last one, we think that internet's allowed to allow university to reach larger number of students, and it's easier, but it's hard to build human community and relationships. That would be all.
Yeah, absolutely. That's a good point. That's the thing. We do have access to a lot more lecturers, a lot more content, but at the same time we lose some of the physical interaction, or we have other logistical challenges which we have to try and implement. Thank you all very much for your contributions. If you have anything else that you wanted to add to that conversation, please feel free to add comments in the chat too. But now I'd like to hand back over to George, who will introduce the next segment.
Okay, thank you, Nate. Our next speaker is Professor Alim Rustam Aslam. He teaches at Istanbul Technological University, more commonly known as ITU. He teaches spacecraft system design at ITU and also at the Air Force Academy. Rustam, you have the floor. Please put up your slide.
Thank you. Let me share my screen. Okay.
Can you make it full screen?
I will. Okay, I'm going to present the activities of UNISEC Turkey for the last 6-7 months, to say. Some information about me, we can skip that. So I am from Istanbul Technical University, the third oldest technical university in the world, actually. The astronautical engineering is since 1983. As UNISEC Turkey, we were established in 2011. Actually, we had a visit in 2010 to Prof. Nakasuka and the RAI. Then we decided to establish the UNISEC Turkey. And what is going on now? We are about to establish the UNISEC Turkey as a legal entity, as an association. I think we will finish that in about a month, and we will be, now we are working as a group of universities, then we will be working as UNISEC Turkey. And instead of universities, we will have professors, members from universities and industry. So some earlier photo meetings. So this is our history. There is a lot going on related to UNISEC activities, CLTP, MIG, and all other meetings. And we have also other participations in AIAA, APSCO. And now in Turkey, I think during the last 3-4 years, there is a big technological event called the Technology Festival. And it is an international event. We also support and take part in this events. We have already 6 CubeSats launched, and there are 3-4 more projects, and probably there will be more projects. And this was interesting. For the first time as UNISEC Turkey, as students, university students, we organized the CANSAT competition for high schools. Then the pandemic came. Anyway, we continued the contest, and all the evaluation was done virtually. This was interesting. And the APIS group, they managed, and all the teams, they were in different cities. For the final day, they gathered in their schools with their teachers, and they presented their work. So it was fantastic. Then we had 1, 1st, 2nd, and 3rd prizes given. Sorry. Then in the Technofest, we had the CANSAT contest. Then our team So this is the ceremony afterwards. And we have also took place in AIAA CANSAT. One of our teams took the 4th place from Zonguldak University. And in our 4th year course, spacecraft system design, last year, the project was Lunar Base Camp. This year, the project is Mars Ice Core Sample Return. So this is a draft concept of operations. That's a hot topic, Mars. And again, one of our members did the first Pocket Cube to be launched in the coming months. And here, I think recently we have launched this, and now in international cooperation, we are trying to complete this one. Actually, it was going to be launched, but due to COVID, hopefully it will be launched by the end of this year. This was a cooperation between Turkey and Japan. This satellite is deorbited after being in orbit for about 2 years. Then an international project for X-ray detection and a dual camera system. We are developing a dual camera system for that. Here you see the engineering model. We will finish the integration and testing in about a month or so. And well, ground station and such, that's a complete project. This was just placed into orbit. Work is going on with the satellite. And that's another important project for us, the training CubeSat. This is different than HeptaSat. We have developed a special board, onboard computer, which could be used for such CubeSat. It's very affordable, and actually you can develop actual CubeSat software, the other equipment being very cost-effective simulative systems. And this year, there is also Technofest 2021. There is CanSat and the rocketry and many other competitions. Everybody is welcome to attend, and the prizes are very, very good. And the national space program was announced. That's also exciting, and we are expecting lots of support from the Turkish Space Agency. And there is an interesting mission. So in about 2-3 years, there is a project to shoot the moon, literally, actually. We can discuss. And another thing, like the Japanese GPS system, there is a project to develop a similar system. And today we have two information from 2 members. One is Middle Technical University Aerospace Engineering Department. Now, one of our former students, he is also a graduate of Japan. And he worked also in JAXA, and he is attending the meeting. As you see, they also they are aerospace department, not space, and the major is the aero. But now I think with his contribution and with contribution of some other faculty members, they will be also doing a lot in space technology development. And also they are lucky because with the new space program, there will be a space technology development in their campus, which is good. And they have also a CubeSat project within UPSCO, and they had some other projects as part of European projects like the deorbit sail. They also take part in CanSat competitions. And they have also many other activities. Now, what is important, they are getting ready for MiG-7 and some other similar international activities.
Rustam, sorry to interrupt. You have 2 minutes left.
No, it's finished. And there is another member, University of Turkish Aeronautical Association. They were established in 2011, and they are doing lots of studies like star clustering with machine learning and orbit design, LEO to moon. So you can see, and also they are trying to find the best orbit for GPS satellites. And for the next year, we have a lot to do to work with the Turkish Space Agency to get ready for 11th Nano Satellite Symposium. Let's see what happens first. 2021 should take place. And we have probably we will be doing a project for Department of Meteorology with a meteorological payload. So thanks for following.
All right, Rustam, thank you very much for that 10-minute update on your activities in Turkey. I want to jump right into the next speaker now. Our next speaker is Dr. Hiroshi Koyama. He's currently Fellow of Electronic Systems Group at Mitsubishi Electric Corporation, also abbreviated as MELCO. So without further ado, I invite Dr. Koyama to put up his first slide. I see it's there already. You have the floor, Dr. Koyama.
Okay, thank you very much. Okay, thank you for this for kind introduction, and thank you for providing me this excellent opportunity. Our company, Mitsubishi Electric Corporation, MERCO, is considered to be typical example of legacy space company. That is so-called old space. But today, I'd like to introduce new direction of our space business after brief introduction of our legacy space business. Please go to next page. We have kept good and close relation with UNISEC. In 2011, Nano-Satellite Constellation Mission Idea Contest was held in University of Tokyo, and our MERCO team presented idea for integrated meteorological precise positioning mission utilizing nano-satellite constellation. And we succeeded to get first prize. It was a great honor for us. And we also support UNICEF various activities such as global meeting and space job fair and etc. And I'm an advisory board member of UNICEF. Please go to next page. This slide shows history of our space business, legacy space business. We started the space business from 1960s. At present, our company is top satellite manufacturer and leading company in Japan. As shown in this figure, we have participated in more than 500 satellite projects. We got about 70 awards as prime contractor, and we provided over 500 onboard equipment to domestic and foreign space companies. Please go to next page. This slide shows space business area of our company. In the communication area, as shown here, MERCO established a strategic standard geosynchronous platform named DS2000. Using DS2000, we got contract from Qatari, Turkey, it's a Turksat 4A and 4B, and Singapore, Taiwan Telecom, and others. Regarding Earth observation area, we have provided various types of Earth observation satellite using optical and synthetic aperture radar sensor. In navigation area, we have developed Japanese regional navigation satellite system named QZSS. It's a coordinate satellite system, the prime contractor. And in space exploration area, we have developed space telescope systems and ground-based telescope such as Subaru in Hawaii Island for astronomy. And for transportation to ISS, we have developed and operated H2 transfer vehicle, it's HTV, to supply logistics to the ISS. These are traditional area of our business. Next, I would like to introduce our new direction of space business. Please go to next page. Recently, we have started new business activities that is utilization of space systems. First area is navigation. QZSS is Japanese regional satellite positioning system. QZSS has two major functions. One is GNSS complementary. That means QZSS can improve positioning availability. The other is positioning augmentation. This is very important. QZSS can improve positioning accuracy and provide centimeter class augmentation signal in Japan. We call this signal CIRAS. By using CIRAS, it's possible to get positioning information around about centimeter accuracy everywhere in Japan at present. There are various application fields of this CIRAS. Major application area is automated driving. To utilize CIRAS or automated driving, CIRAS user terminal and 3D digital map are necessary. 3D digital map that is dedicated for automated driving is called dynamic van, as shown in this figure. We established a company named Dynamic Map Platform to provide this 3D dynamic map. This dynamic map company already generated Japanese all highways 3D map. That is the present situations. Please go to next page. Next area is Earth observation data utilization. Major Earth observation data is from optical satellite. In addition to data from optical satellite, our company plans to utilize data from synthetic aperture radar satellite in more active manner. And we are promoting to combine information from space systems and big data cloud AI techniques to produce future new business and solutions. Our main goals are solutions for disaster monitoring and also solutions for maritime domain awareness. Regarding disaster monitoring, we plan to provide monitoring information of social infrastructures such as building, roads, bridge, and etc. after natural disaster as fast as possible. It's our second directions. Please go to next page. Third new direction is small satellite. Our company has experiences to develop and integrated various kinds of observation satellite, such as large multi-platform, high-resolution imaging satellite. It's a middle and large-class satellite. But recently, we had started to develop small satellite. Shown this figure, we already developed the satellite named SLATS and RAPIDS-2 for constellations and next new solutions. These are three directions recent our new activities. Merck would like to make various international cooperative activities in these new solution areas. Thank you very much for your attention. It's all my presentation. Thank you very much.
Okay, Dr. Koyama, thank you very much for this corporate presentation.
Thank you.
Actually, you finished early, so we can take one or two questions if
Okay.
anyone has a question. If you have a question, please go ahead.
Can I ask a question, George?
Yeah.
Ah, from Taiwan,
Yeah,
Dr.
I'm
Jing.
Jin Zhuang from Taiwan Cheng Kung University. About the question, I'm interested in the CLS. Does that cover Taiwan region?
The problem is that it's recently it's only domestic. But
Okay,
sometimes we are talking some kind of people in Taiwan about the utilization of the signal in Taiwan Island.
Yes, I will
technically
be interested
it's
in to
possible.
see how, if we are interested in how can we proceed. No, that's the question. Okay. Thank you.
Maybe you can continue offline.
Okay.
Is that
Okay.
possible,
Okay.
Dr. Koyama?
Okay.
I know Professor Zhuang very well. He's a good guy.
Thank you very much.
Thank you.
Ray, we're coming up on 11:45, so is it okay if I turn the floor over to you?
For this month, we do not have a new local member. So I just encourage you to establish your own UNISEC. And what is needed is just 2 or more university members. Then you can establish your own UNISEC. Just contact me if you have any questions. Okay, and next one is the, let's see. Something is wrong.
No, it's okay.
Okay, so new members, we have a new university member, Kathmandu Engineering College, Professor Stephen Mananda. Student representative is Chief Narayan Kunwar. The UNISEC Nepal always report new university members. So I would like to encourage you to report if you have a new university members. A new corporate member is the Teaching Science and Technology Inc., TSTI, which is the training company, space engineering training company in the United States. And also, I'd like to introduce new point of contact from Kenya, Mr. Daniel Odido. Mr. Daniel Odido, are you here?
Yes, yes, I'm there.
Okay, so can
Yes.
you say some words for some message or self-introduction or whatever?
Yes, thank you very much. My name is Daniel Odido from Kenya. I'm an aeronautical engineer, and I've been working on aerospace projects for some time. So we are currently developing a nano satellite for Earth observation at our university, which is Moi University in Kenya. And we are very excited to join the UNISEC team. And we expect that we'll be able to communicate with the other members within the organization. So thank you very much for welcoming me.
Okay. Thank you very much for your participation, and they will be happy to have you here. And now UNISEC Global Community we have 21 local chapters, 174 university members, and six corporate members. The next virtual meeting is March 20th, same time. And the program is the confirmed speaker is Ken Biba from AirPac. And we have not decided what we'll talk in breakout discussion session. If you have any ideas, please let us know. And local chapter presentations, we will invite UNISEC India and UNISEC Thailand. In corporate presentation, Jerry Serra of TSTI will make a presentation. And the virtual UNISEC global meetings will take place on the third Saturday almost every month this year, the same time. Okay. And 2021 planning, more opportunities will be available. Yeah, I have some the agenda, but I'm not allowed to tell you yet. Maybe in April we can make an announcement about the things that we are talking with Jackson now. And with currently we are organizing Mix 7 lectures, Mission Idea Contest for Deep Space Science and Exploration with nano micro satellites. And the two, we have 3 more lectures. And February 15th and 18th lectures will be uploaded on the website. So you can watch if you are interested in it. And registration is required. It's free of charge, but you need to register if you want to join. The STSC United Nations Scopus, usually it's organized in February, but it was postponed April. I think it's already decided in April the 19th, 39th, they will organize the conference, and I'm thinking to join this meeting as UNISEC Global. And Mix 7 abstract submission due is July 7th. So it seems that there is plenty of time, but time, as you know, time flies. And April South 2021 will be held in November in Vietnam. And please let us know your event information. We'll be happy to introduce here. And the next one is I need to, this is a sort of sad news. In the end of 2020, our colleague and friend and the great advocate of UNISEC activities, the Professor Plamen Dankov, point of contact of UNISEC Bulgaria, passed away. He was because of post-COVID-19 complications. He has served UNISEC Global and also Mission Idea Contest. And actually in 2019, his team was selected as one of the finalists of the 6th mission idea contest, and he came to Japan and he made a nice presentation at the University of Tokyo. So some of you met him at the time. And thank you very much for your contribution, participation, support to UNISEC activities. We will never forget you. It's a sort of sad news, and I really hope that no one will die this year. Thank you very much. So let me stop. Okay. So we have 6 minutes left. So I would like to invite anybody who wanna talk something, or if you have any announcements.
Oshima-san, is it okay?
Yeah.
Okay. So let us start the video. Can you see us?
Yes, Derek.
Hello. Yes. So this is Derek, and I'm Fed. We're both students of the Kyushu Institute of Technology. We're members of the BIRDS 5 CubeSat project. Thank you very much for today. We really appreciate the all the presentations. And okay, so I'm being part of this because I forgot to register. Sorry for that. We just want to announce that tonight or today will be launched the BIRDS 4 CubeSat. So our senpais, the people that were before us, so we're in BIRDS 5, but BIRDS 4 will be launched tonight in 2 hours 40 minutes. So normally 2 a.m. 36 in Japan. Sorry for that. So it is announced that okay, we will launch so 3 CubeSats, 3 1U CubeSats. One is the first CubeSat of Paraguay. The other one, so it's named Guarani 1. Guarani 1, yeah. Yes. The second one is Maya 2 from Philippines, and the third one is it Tsuru? I think Tsuru, yeah, from Japan. So yeah, and we just sent the link in the chat. It is on the official website of NASA. So please, I don't know for everyone living in Japan because it's pretty much late, but everyone who wants to watch it, please, we invite you all to watch it. Thank you very much.
Thank you.
Oh, thank you very much for it's a very nice announcement. I really hope that the launch will be successful.
Thank you very much.
Arigatou
gozaimashita.
Good luck. Good luck.
Okay.
Thank you.
So so who else wants to talk something?
I want to ask a question if that is okay.
Yes,
I'd want to know that if I did not attend the first 2 lecture for Mix 7, is there any recording that I can access or anything?
Well, I think we recorded that, and I think we will send the link of the recording to the registered the participants.
Okay.
So
did you register?
Yeah, I did.
Then,
okay, yeah.
Then you should be on the mailing list, and I believe Kawashima-san released the video for Professor Funase.
Okay. Then I'll check my email. Thanks. Thank you.
Which one? Are you talking about the Mission Idea Contest lecture?
Yes.
Okay. Well, the Professor Funase's lecture is already uploaded. So just go to the Mission Idea Contest website and go to lecture, and then you will find the link.
Okay. Thank you very much.
Okay, thank you. Who else? Do you have any question or suggestion or opinions? If not, nothing.
Go ahead. This is unusual that we have free time left over.
Yeah. Yes.
Can I speak up a little bit?
Yeah, please.
Do you mind if I send the link to the LEGO website to if you'd like to support my LEGO project?
No problem.
No
please,
problem.
please.
In fact, I invite everyone to support Dr. Arai because he deserves our support.
Thank you very much. Appreciate your support. Thank you.
Hey, Chris, please say
Hey,
something.
George. I was just saying, I like the spacesuit design. I've already voted, and I put out some publicity over social media. So I hope we get a surge on that. It's a very nice piece of work.
Thank you very much. I really appreciate your support.
Yeah.
And sharing this SNS.
No, there's a lot of space Lego fans out there. Yeah. I have the theory that pretty much many people who work in space started off with Lego when they were kids.
Hey, Chris, do you have any announcements for ISU?
Do I have any announcements for ISU? Not at the moment, George. I mean, we've just finished our Australia program, which was actually online. And we're waiting, you know, and we're gearing up for our summer program, you know, yeah, at the moment, and the master's program, which I'm running, is all running remote. So a lot of the questions about online workshops today were very topical. But just at the moment, you know, I mean, not a lot of news from ISU. We're just keeping on going, like I think a lot of us are.
Well, I notice you often attend these UNISEC global meetings. We appreciate your support.
I wish I could get ISU to join. You know, Ray and I have had a go at that, but just at the moment, that seems to be a bit difficult. But my ambition is that one day the ISU will join UNISEC, but haven't managed to make that happen yet, unfortunately. But very happy to turn up when I can. So yeah, it's a great idea. Oh, and just I guess a message to Ray. Actually, I just noticed today, Ray, that you got that award from the International Academy of Astronautics in September or something. I've only just found out about that. So congratulations, Ray, for that.
Oh, okay. I see. Thank you. It's 12 o'clock in midnight in Japan. So I think we should say goodbye to everybody. I'm always I'm always crying when I need to say goodbye to you. But in the last minute, if there is anybody who wants to say something, just one or two, it's okay.
I think I'd just like to say I have very happy memories of being in Tokyo last December, you know, or a year ago last December. Seeing some of the faces today brought that all back to me. It was very nice being at the UNISEC event the last time I met most of you in person.
Okay. Kuros-san, dozo. No? It's just, okay.
I just wanted to say hello to Chris.
Okay.
I'll turn my camera on so you can see me. Hey, how's it going?
Good. Okay, so SSP of the summer session program of ISU, I think deadline is the end of March. The application deadline is
The applications, yeah.
So if you and
it's going to be split actually between Granada and Strasbourg, so half and half. So it's unusual this year because the university in Granada has limitations on how many people it can accommodate.
Okay.
So it'll be our first split site SSP.
Yeah, and I heard that the complete online course is also available.
And there will also be yes, and then there's a third part of it which is just online. So
okay. Yeah. Well, I really hope that we can recover. We can solve the COVID-19 problem quite soon, and then getting together and then having a dinner together. It's very nice. It's important for me.
No, good. I hope many of us see each other in Dubai in October.
Yeah.
If not before.
Okay. Oh, Professor Khalil, Mohammed Khalil. I think I saw you. Please make some comments from Egypt. You should unmute.
So I'm very pleased to attend this meeting, and I hope that I will have the opportunity to attend actually every meeting. It was very informative and beneficial, and I think this is very good actually to keep such meeting during the COVID-19 pandemic. So good. Best of luck for all of you, and thank you.
Oh, thank you very much. And Marcel, do you want to say something?
Hello, everyone. I'm trying to attend all meetings, but due to my education currently going on Saturday, unfortunately, just after my executive MBA program, I'm trying to attend the program. And it's going very well as far as I see. We have a very large community. We have corporate members also growing. My suggestion, maybe in each country who has local chapters, maybe we should try to find local corporate members also. It might be a good idea to growing further for UNISEC. And thank you. Thank you, everybody.
Okay, so thank you very much. So it's time to say goodbye. So, but good news is we'll have next meeting in March 20th. So let's meet next month again if you have time. And the Zoom link is same. So if you well, just forget for registration, just use this link and you can come. But of course, we would be happy to if you kindly could take some time for registration, because we are always taking some short questionnaires. So thank you very much. Oh, Nakasuka Sensei, どうもありがとうございました. Thank you very much, Nakasuka Sensei. He's really busy, but he always helps us. Thank you very much.
Thank you. どうもありがとう.
Okay. Thank you. Okay, so who else? So well, I think somebody wants to say something. I assume. No. Sibyl, do you want to say something?
Oh, hello. Thank you for your presentations. All of them was very informative. Thank you for the meetings. Unfortunately, I couldn't involve all of them, but I'd like to meet you in March again. Thank you for the presentations again.
Thank you. Sibyl is a CLTP 8.
Yes.
8. Yeah.
8.
Yeah, and the Professor Khalil and Maso, they are CLTP 1. And CLTP 1 was a very, very tough year because we had the earthquake and big earthquake in 2011. So it was really difficult the time, and the first year is always difficult, and because we didn't have any kit of cancer or hepatitis, nothing. So they had to make cancer from scratch without instructors. It's a really difficult time. And they had to go through the very difficult earthquake experience. But you know, due to these difficult experiences, Professor Khalil is now the Vice President of Egyptian Space Agency. So I think our CLTV training made him strong. Made him strong and made him smart. I
Definitely. Yeah, thank you.
So thank you very much for joining us, and I really hope that we will meet next month again. And please stay positive, stay safe, and stay happy. Thank you.